Hey students, today we are going to learn about the topic number 5.3, which is the resistivity and resistance, and that is from the chapter number 5, current and resistance. So first topic, what we are going to learn, the basics of Ohm's law. What exactly the Ohm's law says? Ohm's law says the electric current, okay, electric current flowing through a conductor. Let's say we have a wire with us and the current is flowing through the conductor. So that is directly proportional. So I is directly proportional to the potential difference. So means directly proportional to V. And once we able to solve this, okay, solve this directly proportional, then we will get I is equals to V over R. And we can, if we simplify this, then V is equals to IR. Fine, guys? Okay. That is our simple Ohm's law. Okay, now here is the first word. V is the potential difference. Okay, as we know, I is the current, we already know. But the third factor, that is the resistance. Resistance means the problem occurs when the current is flowing from one position to the another position. So guys, this is our second term, that is the resistance. I told you resistance means problems. Okay, problems in the path of the current. So this is technical part, how the definition is there, is defined as the ratio. Okay, that is the ratio. We know V is equals to IR. So we can use this triangle to solve the R. So can I say R is equals to V upon I? So now just go back to the definition, is the ratio. Okay, ratio of whose value, which value? Potential difference divided by current. So ratio of potential difference V applied across the ends of the conductor to the current I flowing through it. So it's a ratio of potential difference per unit current. Fine. And the unit is ohm. What is the unit? Ohm. Fine. Okay. Now I already told you the unit is ohm or volt per ampere. And this is the symbol. This is the symbol. And we called it omega. 1 omega is equals to 1 volt divided by 1 ampere. Fine, guys? Okay. Now the major thing on which you need to focus more, the factors. Let's say I will take a simple example of driving. Let's say someone is driving a car on the road. So first thing, what are the different problems you can see on the road? Okay, in a same way, I'm going to correlate this thing with the wire, and the electrons are flowing through the wire. So there are lots of factors, and we are going to study two major factors, or you can say the three major factors. The first is the length. More you need to travel, it's a high probability that you will get the more problems. So we will say resistance is directly proportional to the length of the wire. Bigger the wire is, bigger the problem is, because we will find more problems. Okay, so R is directly proportional to the length. Second is the cross-sectional area. Okay, now guys, I have a question for you. Let's say you have a very small road, very thin road. This is the road 1, and the second road is very thick road, very wide road. Okay, just tell me on which part it's easier for you to travel, on road 1 or road 2. Of course you will say, sir, road 2 we can go easily with higher speed. And with this word speed, if you say with higher speed, so you can relate this word speed with your current, okay. So means higher the speed, higher is the current. It means more area, less resistance. Less resistance, if resistance is low, then current is high. Clear, guys? So these are the two factors. Third, we called it type of material. As we know, we have the different type of materials. Let's say we have the conductors, we have the insulators, we have the semiconductors. So right now I'm going to discuss about the conductors. Even in case of conductors, some are the normal conductors, some are the good conductors. So what does it mean? That if you have a good conductor, it means the conductivity is very high and the resistance is low. Okay, and for the type of material, we generally studied a word called resistivity. A word called resistivity means the ability to oppose the current. So resistivity is a measure of how strongly a material can oppose the flow of electric current. Clear, guys? So we have the three factors: R directly proportional to L, R proportional to 1 over A, and once we solve these two factors, let's say equation 1, equation 2, then we get R is equals to or proportional to L over A. Once you solve it, rho L over A, where rho is the resistivity. And if we find the value of resistivity, rho is equals to R A by L. Okay, guys? Clear? So this is your major equation or major formula. Okay, second thing, how just this is the relation you need to remember, that we have a relation between density, electric field and current density, which is direct relation you need to remember, that is rho equals to E by J. Fine, guys? Okay. Now there are small things you can just find out the relation. So E is equals to V over L, we know this thing. J is equals to I over A. From the previous videos we know all these things, so you just need to place the values. Okay, you know now rho is equals to E by J. Okay, E is equals to V over L, J is equals to I over A. Place them. Okay, we know rho is equals to E by J. Place the values. What is E? V divided by L divided by I divided by A. Okay, so this will go here, this will go here. So can I say V A divided by I L? Clear, guys? Okay, what is V? As we know, V is equals to I R. V is equals to I R. Place it. I R A divided by I L. Okay, so you can cancel I and I. So what you get? R A by L. So which is the same, rho is equals to R A divided by L. Clear? Fine. Okay, now the unit. So as we know, we have rho is equals to R A by L. Okay, for R we get ohm. Fine. For A, area is meter square divided by length is meter. So 1 meter cancel. So what we get? Rho meter. Clear, guys? Okay. Now we have the two more words. That what is the meaning of conductance? Just think. You recently learned about the resistance. So opposite or one upon of the resistance is called conductance. A very simple thing. 1 upon of the resistance is called conductance. Similarly, you have the word called conductivity. What is conductivity? Just think. You learn about the resistivity now. So conductivity should be 1 upon of the resistivity. Clear? Okay. Now go back to the conductance. So conductance, the unit should be 1 upon ohm, or the name is Simon. Clear? Or here you can say Simon per meter. Fine? Yes.